Okay, so hello again. This is a backward indexing method for alligation as compared to last time forward indexing method for alligation. In this method, so the index here, like k for example, k here extends from the last index n, the biggest index, n minus 1, and so on, until 3 to then 1. So that is why this method is termed as backward indexing method for alligation. Okay, so in this case, we have 4 propositions, 1, 2, 3, 4 propositions, which are similar to the case of forward indexing method. And here, you should remember that for index k, it is you start by the largest indexing, then the 1 unit less than the previous, and so on until you get the first unit 1. Unit 1 comes last. Okay, in this case, first proposition is about the weight, how you can express weight, and especially when you know the quantities. But when you don't know the quantities, here you need at least one quantity. Here it is you express any quantity of the components of the mixture in terms of the last component for the last component of the mixture. If you know the quantity, the rest is about ratios. These ratios, n minus j, it will be equal to quantities q kn minus just minus j over qn q sub n minus okay, j plus 1 in this case. That is the expression in terms of quantities. In terms of weight, so it will be equal to omega sub n minus j over omega sub n minus j plus 1. Okay, we are not going to just prove this one because it is similar to the case of indexing, forward indexing, except that, for example, in this case, you know that in case of instead of dividing the expression of giving the weighted mean value p bar, instead of dividing both sides by the first weight like we did before, we divide by the last weight. That is why qn is considered as the quantity that you should know in order to know others. But if you don't know others, if you don't know this one, the last one, but you know one of the remaining ratios, n minus 2, 1, so you can calculate also by using this formula, taking into account the indexing as indicated here backward. Okay, so now let us just read quickly these propositions. So here, if we know at least n minus 2 ratios, Rj, here we said Rj, we can say n minus j, no problem. And we don't know any one of those ratios, n minus 1 ratios. So we can use this interesting formula, this formula here, in order to find the particular ratio. Okay, so now let us read the first proposition, which can be together with the second, third, and the fourth, which can together be used to prove this interesting formula. We termed it as interesting formula. So in this case, the first proposition is telling us that if we know the quantities for the components of the mixture, we can express the ratio, the fraction of each quantity. It gives the weight, and the sum of all weight starting from n until 1, it will give you the number 1, which means that these weights are a normalized weight. Normalized weight. These are normalized weights like before. These omegas have some indexing. Okay, that is the first proposition. Proposition number 2 tells us that if we know the last quantity, Qn, we can express other quantities in terms of the product of ratios of those quantities. Okay, that is proposition number 2. Is this one. Proposition number 2. So proposition number 3. So the weights can be expressed in terms of product of the ratios, not the reciprocals of the ratios, but directly the reciprocals, like in the second case in the proposition number 2. Okay, so number 3. So those product of ratios can also be used to express the any given weight. Okay, finally, proposition number 4. You have ratios, the overall ratio in terms of product of these particular ratio, 2 by 2 quantities ratio, and then you have this proposition over here. It is this one. Okay, so we are going to give some examples in order. We cannot prove this one because it is proved in the similar manner like the one we saw for forward indexing. It is similar. So if you wanted to see the proof, go back to the previous video in order to see how we proved those 4 propositions in another case for forward indexing. So in this case, we give examples for each proposition. Let us start by the first proposition. We just give an example. Let us start by first proposition. Now, proposition number 1. So, and we give example for case when equal to 3. Now, the first proposition number 1. So we have the quantities for the first component of the mixture, second, third, and we know that they will give the quantity of the mixture. Now, in this case, first proposition is telling us that is the fraction qk over q, it is going to be weight, and this weight, it is be normalized weight. Weight for indexing k, belonging to the set including 3 2 or 1. In case here indexing, this is not the indexing we want. Sorry, I have in mind for forward indexing. Let us use backward indexing in order to match this condition. So we have a q n, it is 3 minus k plus 1 omega 3 minus k plus 1. So you see that if I take k equal to 3, this is n, then I'm gonna get q index q sub 3 minus 3 plus 1 is equal to over q. This will be okay. Similarly, omega sub 3 minus 3 plus 1 will be equal to omega 1, and this omega 1 will be like q 3 sub 3 minus 3 plus 1 over q, which is exactly q1 over q. Okay, for index k equal to 2, you're gonna have omega 3 sub minus 2, 3 minus 2 plus 1 is going to be omega 2. 1 plus 1 sub 2. This is q also 2, q2 over q. So k equal to 1. So you're going to have omega sub 3 minus 1 plus 1, which is omega sub 3, which is also, after substitution, value of k, you get q sub 3, q sub 3 over q, q being the sum of all values. Now here, this is for the first proposition. Now let us move to the second proposition. What the expression, what it says. Second proposition tells us that if you know the last component, this is qn, in case index n is 3. So here we will have, if it is known, then we can compute all other quantities. qn minus k plus 1 sub is qn product j extending from 1 until j equal to sub k minus 1 r n minus j. Okay, so let us take n equal to 3. Then we are going to have for k equal to 3, which is n. So we will have, as we have said, it is q 3 minus 3 minus 3 q1, that is q1. It will be expressed in terms of q3, q sub 3 product from j equal to 1 until j equal to k. So k equal to 3 minus 1, r n equal to 3 minus j. So this is finally equal to q3 product of ratios from j equal to 1 until j equal to 2. So this means that if I want to calculate q1 knowing q3, so I have this equality. This means that finally q1, this is to say that q1 is equal to qn, q sub 3 times 1 over, let us see what happens. J extending when j equal to 1, you will have from r index 3 minus 1, first it is 2 sub 2 times 1 over r sub 1, because we are going to go up to 3 minus 1 first is 2, 3 minus 2 it is sub 1. Okay, so now this it is in the case k equal to 3. Now k equal to 2, for example. I mean k equal to 2. Yes, we are going backward from 3 to 2, then 1. So we have Q2 here. Q2 will be expressed in terms of Q3. By which product then? We take product from j equal to 1 until j equal to k. K here is 2. This will be 2 minus 1 according to the formula here. Then R sub n is 3 minus j. Okay, so what it is Q sub 3 times the product from j equal to 1 until j equal to 2 minus 1 is 1. So which means that R, we will have R sub 3 minus j, which is Q, which means that Q index 1 is Q3. Q sub 3 times now as we extend from 1 to 1, so it is only R sub 3 minus 2, which is 1. Okay, now finally, of course, if we take the last one is a particular case. In the case k equal to 1, so we have q1 is equal, of course, q3, sorry, q3 is equal to q3. And it is an identity, which means that when in general product from ratios from 1 until 0, so it is always equal to 1, which means that Q, we express every quantity in terms of the last one. The last one is 3, so we no longer have the last 3 except itself. That is why this relation, we have just an identity, which is true. It is normal, we don't have any problem. And in the case n equal to 3, then we have also 1. Okay, so this is about proposition number 3. Now we can move on for proposition number 3. Proposition number 3. We give an example in case n equal to 3. That is, in the case we have a mixture of 3 different components. Now we are talking about proposition number 3. Number 3. Okay, what does it say? It says that we can express weights. These weights, n minus k plus 1. These weights, these weights can be expressed in terms of ratios by the ratio product of these ratios are n minus j from 1 until I minus k. Okay, from j equal to k minus 1, divided by sum of them. Suppose I from 1, from n backward method until I equal to 1 of these products. These products of these ratios from j equal to 1 until j equal to I minus 1. Here, this because it is j, but for index, for of the whole index in k, it is from n until 1. Okay, so now in the case n equal to 3, we have situation here. In general, n sub, let me use another pen, n sub 3 minus k plus 1. So this is equal to so product So let me just change here n equal to 3 in order to save space. 3 here, then 3 there, and then 3 here too. And then I start from 3. I equal to 3. Okay, so let me take k equal to, suppose, 3. So I'm going to have substitute here. This will be the first one. I change. If k equals to 3, this will be omega 1. And this omega 1 can be expressed in terms of the product of ratios. So here, I'm going to have this ratio. This fraction will be product from j equal to 1 until j equal to k equal to 3, k minus 1, k minus 1, 3 minus 1 over r, 3 minus j over sum of them from I equal to 3 until I equal to 1. Product j from 1 until j equal to. Now I no longer need to write it again. 3 minus 1 is just 2 over r sub 3 minus j. And what is it? I keep this as a general formula for the three weights. Now with k extending from 3 then 2 then 1. So I have started by k equal to 3 as the first case. So in order to obtain w omega 1, so what is it? Let me have it here. This is equal to numerator. Numerator will be, so I start by 1 until 2. Rj 3 minus 1 will be 2. 3 minus 2 will be 1. R sub 2 times R sub 1 divided by sum of all of these products. It means R2, R1 plus now go backward, R1 plus now 1. If you take this sum, you're gonna get those one. So this is omega sub 1. In case k equal to 3. In case k equal to 2, what am I going to have? K equal to 2. So I'm gonna get same formula, 3k plus 1 is equal to, so you are going to substitute 2, you get k equal to 2, you get 1 plus 1 is equal omega 2, omega sub 2. So omega sub 2, we are going to find that, okay, immediately let me tell you what I'm going to get. I'm going to sum from here, if I use this formula, so k equal to 2, so I'm gonna get from 1 to 1. 2 minus 1 is 1. So from 1 to 1, I'm gonna get r 3 minus 1. So which will be r sub 2 over r sub 2 times r sub 1 plus r sub 2 plus 1. Okay, so next, when k equal to when k is equal to now 1, what will I have? So I'm gonna have, in this case, I'm gonna have omega sub 3 minus k plus 1. When k equal to 1, I'm gonna get 3 minus 1 is 2, 2 plus 1 is 3, omega 3, omega sub 3. Omega sub 3 is going to be equal to, so finally it's going to be equal to 1, r sub 2, r sub 1 plus r sub 2 plus 1. So this will be omega 3. Whereas omega 2, as you have calculated, omega sub 2 is equal to this quantity. in the second case. So we have first case, second, third as respectively indicated. Okay, so this is the second proposition. Third proposition, we keep our index to up to 3 as the largest indexing, and we move to proposition number 3. And okay, we don't need to keep this because this expression is for the previous third proposition. Okay, now in this case, what are we going to have? So equivalently to the previous proposition 3, we have proposition 4, which will be look like R2 R1 divide 2 R2 2 R1. It means R2 times R1 per R sub 2 per 1. Okay, this is how the ratio will be formulated in the case of backward indexing method for alligation. Remember that for this is for backward indexing. Recall that suppose because of properties of ratios, if we divide by the same number, you get equivalent or same ratios, equivalent ratio actually. It means that if we want to find to remember the forward indexing method, so it will become 1 here, then 1 over R1, and 1 over product R1 times R2. It means that if I divide each term by the product of the two ratios, I'm gonna get the equivalent ratio. This is what every time it works in this formula. Now, still for the case number 3, we keep n equal to 3, but it could extend any number greater than 2, greater or equal actually. In case of n equal to 2, we will talk about another video in case n equal to 2, which is a special case for method of alligation. So now here we will consider this proposition in case of n equal to 2. This formula, in case equal to 2, how can you write this formula? This formula is written as so we sum R2 times R1, now P1 plus R2 P2 plus I forgot again. Here I have to multiply by this difference. First of all, P1 minus P bar plus R2 P2 P bar plus P3 minus P bar equal to 0. This one is my favorite expression. Instead of doing the forward indexing, this is for backward indexing. So what I like most is this backward indexing because it is easy to handle than the forward indexing method, as we saw indexing method, in which case this equation is equivalent to when I start by P1, divide both all term by this product, you are going to get the difference, P1 over R1, P2 minus P bar plus P3 minus P bar over R1 times R2 equal to 0. So this one, forward indexing method, this is what we used the last time. Now we're going to use this expression for this time, backward indexing method. So obviously, if we set as for some examples that we used, we said that if R1 is equal to a half, what will be R sub 1 in order to find the ratio? Okay, so in this case, we given, for example, for our last case, we have P1 equal to 200, P2 45, P3 50, and for the mixture we have P bar is equal to 70, for example, 70. Okay, so now in this case, we are going to, from this one, what will it be? From this equation, for this equation, this identity, how will I find R1? So I see in the first term, I have R1, nowhere else, which means that I can express R1 as being equal to opposite all of these ones, R2, P2 minus P bar plus P3 minus P bar divided by R2, P1 minus C. So what am I saying? I have R sub 1, I want R sub 2. Okay, I want R sub 2. Or in order not to clean up all of this, okay, let us set R sub 1, R sub 2. What will be R sub 2? R sub 2 is in this term and this term. So I factor this out and I will get R sub 2. This is what I want. I said this is my favorite formula for in this case of alligation method because it is very simple to manipulate. Sub 2, so it's gonna be now R sub 1 is here only, which means that R sub 1 being here, so we want R sub 2 which is here and here, so we have this term on the other side, P3 minus P bar over I remove this one, R sub 1 is known, P sub 1 minus P bar plus P2 minus P bar. So substitution will give you negative something like 50 P sub 3 minus 70 divided by R sub 1. R sub 1 is half. So P sub 1 is equal to 200 minus P bar. P bar is a mean value 70 plus now here P sub 2. P sub 2 is 45. 45 minus mean value 70. Okay, what is it? It is equal to negative what? 50 minus 70, it is negative 20. 50 minus 70. Now, half of this one, 200 minus 70 is 60, is 130 divided by 2, 65. Now I have to subtract because here is negative 25. Yes, negative 25. So this will be negative 20 over 40. This is positive 20 over 40. Simplification is half. So which means that this is R sub 2, knowing R sub 1. So let us work another question. Suppose you have R2 is a half, and suppose you want to compute R1 using this identity, this formula. Because this formula is the case when, a general case when n equal to 3. Okay, in this case, what will happen? In this case, what will happen? So we know the answer from last videos. We know that it will be a half. Let us verify with this formula. Okay, so now here, okay, so here we want to find R1, but R1 is in this term, other terms not concerned, so we have to put them on the other side. R2 P sub 2 minus P bar, now plus P sub 3, P sub 3 minus P bar. Okay, so over, now this term contains R sub 2. So I'm left with R sub 2 here. Then times P1 minus P bar. And this is what I have. Finally, substitution, negative. Numerator, it is half. R sub 2 is half. The second ratio is half. And then P2, P sub 2 is 45 minus 70. The 70 is the mean value. Now plus third value 50 minus 70 mean value divided by R sub 2. R sub 2 is equal to a half again. 150, no, 200 minus 70. Okay, P1 270 is P bar. Okay, now let us substitute and see what will happen. So we have half of negative sign, negative half times 45 minus 70 is 25, negative 25. Now, and this negative will act on two terms, plus 70 minus 50 minus 70 is negative 20. So all of it times no, this will act on the first, and half. Okay, I think it is like this. Instead of this bracket, we consider this one. Okay, now I divide by a half of 60, 130. This is negative, negative, negative. Act on a negative, it becomes positive. So we have 25 over 2 plus 20 over 65. So let me check for any possibility of mistake. If there is no mistake, so R1 here is expressed as this one, half, and then downward we have also a half. So here we have P2. Okay, P2 45 minus 70. So I see that what I will have is, so let me check, it is equal to 25 plus 40 over 2 divided by 65. And this is 65 over 2 divided by 65. And what is this? This is a half. Okay, as it was suggested, this is a half by also this method. So we can continue on and on when we have n minus 2 ratios. See here, because n equal to 3, we will have at least one ratio in order to find other ratios. And the other ratios, when we only have 2. If we have n equal to 4, for example, if we have n equal to 4, we will have to know necessarily 4 minus 2, two ratios in order to find the other three ratios, because in that case we have a total of n minus 1 ratios, total of ratios. So as we have to solve one equation with the n minus 1 unknown, we need at least n minus 2 ratios in order to find one particular ratio. Okay, this is all for backward indexing method for alligation, and we are going next time. This is the end of this video, and we will talk a little bit about what we are going to do in the next video. In the next video, we are going to talk about the rule, what we call the rule for alligation. Rule for alligation. Let me just write this one. It is very important, and sometimes it is in form of a diagram, and we are going to see why from this relation, or either from the previous method. This is what you are going to do. So next time work or video. So what you are going to do. So we have so far we have three methods, three main methods. So the first of which is weighted mean unit mean unit values method. This is the basic method. Others, it is just a kind of indexing method. The first of which, as we talked about last time, is a forward indexing method, and the third one is backward indexing method. Okay, so what we are going to do next time. So three basic methods. So next time we're going to be talking about alligation rule. This rule is a pictorial description of alligation rule. Okay, this is what we are going to do next time. So alligation rule, why we have such a description in terms of a diagram or a picture. That is what we call pictorial description of alligations rule, what we call alligation rules, what you will find on internet calling alligation rules. We are going to describe it, and we explain everything about it and how it came to be presented as a diagram. In that diagram, why do we have that diagram? That is one of the reasons why I have prepared previous videos about alligation. Okay, so now all of this in the next time. So until then, please keep watching. Thanks.